In the first part, we looked at how pipeline inspections often focus on the pipe itself. Visual checks, measurements, and condition assessments are usually centered on what can be directly observed. But most long-term pipeline risks do not begin with the pipe. They begin with the ground the pipe is built on. To understand pipeline safety properly, we need to shift our attention away from the pipe alone and start paying attention to how the ground behaves over time.
Pipelines do not fail on their own. They respond to forces acting on them. A buried pipeline is fully constrained by the ground that surrounds it. That means the pipe does not move independently. When the ground settles, shifts, or slowly deforms, the pipe is forced to follow that movement. This movement does not happen all at once. Stress builds gradually along the length of the pipeline, often without any visible change at the surface. By the time deformation, coating damage, or structural issues are observed, the ground movement that caused them has usually been developing for a long time. The pipe is reacting to what the ground is doing.
There are several common ground-related risks that affect buried pipelines. In hilly terrain, slope instability and slow landslide movement can impose significant forces on a pipeline, even when the ground surface appears stable and unchanged. These movements may be very small, but they act continuously over long periods of time. Erosion is another important ground-related risk. Flowing water can gradually remove soil support beneath or around the pipeline, altering how the pipe is restrained by the surrounding ground. Subsidence can also develop along a pipeline route. Uneven settlement causes different sections of the pipeline to move by different amounts, introducing additional stress into the system. These ground-related processes are typically slow and progressive. They develop quietly, often over months or even years, and are easy to miss during inspections that focus only on individual locations or single moments in time. One reason ground-related risk is difficult to manage is that it develops gradually. Small changes in slope shape, soil condition, or surface drainage often do not appear alarming when viewed on their own. Each individual change may seem minor and easy to dismiss during a routine inspection. There is usually no single moment when ground-related risk suddenly becomes obvious. Most of the time, the terrain continues to look normal and generally unchanged from previous observations. Inspections may show conditions that appear acceptable, even while slow movement or subtle deformation is already taking place below the surface. By the time visible signs finally begin to appear, the underlying process has often been developing quietly for much longer than expected. Ground behavior cannot be understood from a single inspection. What matters is not only what the ground looks like at one moment in time, but how those conditions evolve and change over longer periods. Slow movement, gradual erosion, or subtle changes in drainage often appear insignificant when they are viewed in isolation. Each individual observation may seem acceptable on its own, especially when there is no obvious damage or visible distress. As a result, inspections carried out at a single point in time tend to capture a snapshot of conditions, rather than revealing how the ground is actually behaving. It is only when observations are repeated, carefully recorded, and compared over time that small changes begin to connect and form a meaningful pattern. Time reveals behavior that a single inspection simply cannot show. Without this time-based perspective, inspections document condition but fail to explain the underlying processes at work. When engineers begin paying attention to how the ground behaves, the conversation around pipeline safety starts to change. The focus gradually moves away from reacting to visible damage after it occurs and toward recognizing risk much earlier in the life cycle of the pipeline. Ground behavior often provides warning signs long before any physical damage can be observed on the pipe itself. By understanding how the ground is changing along the corridor, decisions can be made with better context and greater confidence. In the next part, we'll look at how improved visibility across the entire corridor leads to better decisions, not just more detailed reports.